So now we'll discuss another application of cross product or vector product, which is to find the area of parallelogram whose adjacent sides are two vectors. Okay, so let us try to understand it. Let us say again that we have two vectors. Okay, two vectors. This is, let's say, B vector, and let's say this is A vector. They are at an angle theta. Now we know that we can shift the vectors laterally, sidewise or upwards without any direction or without changing their angle. So we can shift this vector here in this direction to get, sorry again, this is slightly, okay, like this. Okay, this is A vector, we have shifted it in this direction, and then we have, okay, again this is, sorry, please forgive my drawing skills, they're not that great. Okay, here. Okay, this is B vector, it is acceptable. Okay, yes. So we have formed a parallelogram. Now if we just slightly extend this and this, okay, this is the height between these two parallel sides. Height, this angle again is theta, corresponding angle theory. This is A vector. Okay, this is A vector. So this height h is equal to A sine theta, where A is magnitude of A vector. Now we know that the area of a parallelogram is given by the magnitude of base multiplied with the height. So here the magnitude of base is B vector modulus, this one, this is the base, and this height is equal to A sine theta. Okay, A vector modulus sine theta. So the area of parallelogram is equal to base into height, which is equal to B into A sine theta, which is equal to AB sine theta. Now if you just try to recollect the concepts, we have already discussed that the cross product of two vectors is given by AB sine theta n cap. It is expressed as this, where n cap is the unit vector in the direction of the resultant vector. Okay, so if there are two vectors like this, let's say A vector and B vector, and the direction of the angle is like this, then the resultant vector will be directed upwards as per right hand thumb rule, A vector cross B vector. and n cap is the unit vector in the direction of that. Now the magnitude of A vector cross B vector, which is the resultant vector magnitude, is A B sine theta. So if we connect the dots here, the magnitude of cross product is equal to the area of the parallelogram formed by two vectors as its adjacent sides. So here A vector and B vector, they are the two adjacent sides of this parallelogram with an angle theta in between them. So here the area of this parallelogram is nothing but the magnitude of the cross product. This, the magnitude of the cross product. So the area of the parallelogram with two vectors as its adjacent sides is equal to the magnitude of cross product. This, okay. So this is another important application of cross product, okay.